The mistake they made on this one was that they tried to combine two unlike denominators. And so instead of, right there.
Can you show them the right way?
The right way, really fun.
Go ahead and circle that. Okay, so we get a common denominator here. We multiply the 1 over a by b over b, so we're multiplying that by 1. We make that an equivalent fraction. That fraction would be b over ab. And then we multiply these together. This one gets multiplied by a over a. We're just multiplying by a 1. So that one's going to be a over ab. Now they have a common denominator, and you can put them together. Very good. Okay, let's see. Logan, you're up on this next one. Tell us what they did here. They didn't multiply the fractions correctly.
So what they did was they did 1 over 3 times x when they should have done 1. Should have done 1 over 3 times 1 over x.
Very good. Very good. Nice job. Okay. So this is almost like factoring. It's kind of like they pulled the 1/3 out front and then they just left the x there. The correct way to do it is to write it, pull out the 1/3. What you'd be left with is 1 over x. Excellent. Nice job there. Okay. Similar problem on this next one. Let's see who we got here. So Alexis.
So they times the x to the bottom, and it should be
Very good. That's what it should be. Excellent. Okay. So I've mentioned this to a couple of you. Writing fractions with slanted fraction bars with that slash there is usually not a good idea. It would be much better to think of that as 1/3 times x. Horizontal fraction bars can get you in trouble. Like if I write 1 and then a horizontal fraction bar and then a 2x, does that mean 1/2 times x, or does that mean 1 over 2x? So if you write it as a horizontal fraction bar, it's a little easier to tell whether the x is in the denominator or whether it's in the numerator. You could fix that by putting a 1/2 in parentheses if you wanted to, or doing 1 and 2x. Okay, that's this one. That's this one. Okay, horizontal fraction bars are a bad idea. I'm not sure why they use those. I realize some people like to keep things on one line, so they use the slash. But that's usually a bad idea. So let me talk about this next one since Hop's not here. So we've got 1 over x plus 2, and it says that's not equal to 1 over x plus 2. Okay, and again, what they did here is they got a little bit confused. They put this in the denominator when it should be in the numerator. So let's write this the correct way. This would be, 1 over x, and then we're going to add 2. And remember I said yesterday, it's better if you think of, if I've got a fraction in a problem, let's think of everything as a fraction. What's the correct way to write 2 as a fraction? 2 over 1, okay? What they did here is they kind of thought of this as 1 over x, and then they said, well, that's 2, that's like 1 over 2 or something like that. Clearly wrong. And then what you'd have to do in order to combine these is you'd have to get a what, Destiny? If we were actually going to put these, you'd have to get a common denominator. So what I need here is I need an x. So I'll multiply by x on the top and the bottom. And that's going to give me 1 plus 2x in the numerator and an x in the denominator. That's the correct way to put those together. Okay? All right. Any questions there? Okay. Peyton, you're up. Hey.
Okay,
What did they do wrong here?
you only add the exponents if it's x2 times x3. So if it's a power to a power, you multiply the exponents. So it would be x2 times, how do you erase?
Just flip it over just like you wouldn't erase it. Turns out.
That'd be x to the 6th.
So the key here is they mixed up the rules. Power to a power, you add, you multiply the exponents. So if we've got an exponent or an exponential expression raised to an exponent, we multiply the exponents. It's this one here that comes next. Tony, what do we do here? You want to come up and show this one? So what did they do wrong? Yep. They kind of mixed up those two rules. Yeah. You don't press it.
No?
Yeah. Okay, so make sure you don't make that mistake. That's most people don't do that, but you want to be sure that you don't. So again, power to a power, you're going to multiply them, so we get x to the 6th. If we're multiplying them, then we just add them. Okay, I kind of think of it as you're kind of stepping down one operation. Instead of raising to an exponent, you multiply. Instead of multiplying, you add the exponents. Okay, Jordan, you're up with the next one.
On this one, they rose the 2 to the 3rd power 2, but it's only the x that should be cubed, so if it's 8x3, then that's 2x cubed. So, because if it's just x cubed, the 2 shouldn't be cubed, because that can be rewritten as 2 times x3.
Yeah. Okay. Excellent. Okay, this one's, I mean, again, a couple of these, I would say these are fairly rare mistakes. Here they cubed both of them. Okay, or if you look at it the other way, they cubed the x but not the 2. Okay, so either way we've got an error there. Miranda, you want to come up and show this next one? Let me show it over here.
Okay, so they tried to get rid of the fraction and simplify it by flipping it and making them negative, but it was already simplified. So, if they...
Some of these are kind of tough to explain or to show an example for.
But their answer that they got, the x to the negative 2 minus x to the negative 3, would simplify to be,
Don't put the button on the side. Yeah. There you go.
1 over x2 minus 1 over x.
Okay, so that would be this expression right here. Okay, that's the right way to write this one. Okay, is this the same thing as that original side there? Nope. No, it's not. Okay. Is that the same thing as this side right there? No, can't do that. Okay. So the problem here is what they thought is, well, I don't like the way that looks right here. You're good. Okay. I don't like the way this looks right here. I don't like that in the denominator. So they use that properties of exponential expressions. If you go from top to bottom or bottom to top, you can change the sign of the exponent. Remember, the negative in the exponent means reciprocal. So they said, well, if I move this up here, I'll just make that x to the negative 2. And if I move that up there, I'll just make that x to the negative 3 and keep the minus in between them. You can't do that. Okay? You can move them from top to bottom or bottom to top if they are factors. Okay? So if it had been 1 over x to the 2nd times, and this really wouldn't make a whole lot of sense, so I'm going to change the variables. Okay? I'm going to put times y to the 3rd. Then that would be the same as x to the negative 2 and y to the negative 3. You can only do that if they're factors. If you were going to take this problem right here and do anything with it, you might write it as 1 over x squared, 1 minus x. You could factor it, okay? That's about all you can do with that one right there, okay, at least for right now. Okay, if I were to take this problem right here, or this side, let me change colors so we can look at this. That would be 1 over x squared as she wrote earlier, and then 1 over x cubed. And the way you can tell this one isn't the same as this side right here is, Destiny, what would I do if I were going to combine these? You'd have to get a common denominator, okay? And if I got a common denominator, what's the common denominator going to be? I could use x to the 6th. I want to use the least common denominator, the smallest multiple of x squared and x cubed. Or think of it this way. This side has 2 x's. This side has 3 x's. What does this one need so that it will be exactly the same as the other one? It only needs another x. So I'd multiply the top and bottom by x. That's going to be x over x cubed minus 1 over x cubed. So that's going to be x minus 1 over x cubed. There's no way that's the same as either of those expressions right there. Okay? Sorry, this expression right here. All right? Not that one and not that one. Okay? So you got to be really careful with those negative exponents and really careful with fractions. All right? Okay, Brandon, you're up with the next one.
So what they did wrong is they tried to pull a 5 out of the equation, which you can't do. But I don't really know like a correct example.
Okay, so is the radical 5x, is that simplified all the way?
Yeah, it's exactly simplified.
It
You can't
is.
go any simpler.
If we got 5 radical x, what would the problem have to have been to begin with?
Would have had to been,
It would have to have been underneath the radical to get a 5 on the outside.
a number.
Mm-hmm. You know a number? So what would have to go underneath here so that we got 5 radical x? It'd have to be an x, right?
Yeah. It would have
5 is the square root
it
of
has
what
to
number?
be 25.
25. Okay? So if the problem has been that to begin with, then we'd have a 5 outside, but you're right. Okay? All right. Let's see. Callie. This is a very common mistake here. I'm going to use more space here. Or you guys can practice writing small.
Okay. So what they did is they assumed that they could just unsquare the x and the a. So that it just do the same thing, but it doesn't.
Yep.
I tested this several times.
Yep. Yeah, you might have to. I mean, it looks like it should work, right? Square root of x squared. Just take the square root of that, you would get x. Take the square root of a squared, that's the a, and then just add them together. It looks like that should work, right? Okay? But it doesn't, because remember, we need pairs of factors. Did you try any numbers?
I tried a lot of numbers. I tried 150 squared and everything because I just wanted to. It always came out as a weird decimal or something.
Yep. And it didn't work for any of them. So let's do this one as an example just to check and make sure. If I have 4 squared plus 3 squared, let's do those separately. Square root of 4 squared and square root of 3 squared. This would be a 4 and this would be a 3, right? But if I square this, I get 16, and square that, I get 9. So I'm trying to find the square root of 25. What's the square root of 25? It's not 7, that's for sure. Okay? Doesn't work that way. So please don't, you can't take the, so the way we say this is, we can't distribute a square root. We can't say that it applies to the x squared separate from the a squared, and then just add those together. Very good. Okay? Again, in order to simplify a radical, you've got to factor everything, and that doesn't factor. Okay? All right. Let's see. Okay, has everybody got these written down? I'm going to make some space here so we can finish this up. Let's see. So we've got Tara coming up for the next one. And again, some of these, it's more of an explanation than I mean, they're just flat mistakes on some of these. So it's tough to say or give an example what we do otherwise. Go ahead. What did they do wrong here?
They weren't supposed to factor the negative out because you can't do that.
Okay. And why can't you? If you were going to pull a negative out, how many would you need in this particular case?
2.
You'd have to have 2 of them, right?
Mm-hmm.
Okay.
So you would just leave it.
Mm-hmm. Yep. Yeah, there's nothing that you can do with that, because if we take the square root of this, if I factor out a negative, I'm left with x minus a. I don't, what? Yeah, you're fine, okay? I don't have two negatives and I don't have two x minus a's, okay? So we're finished right there, okay? So don't think you can just pull that out there. So if you've seen this before, if we were taking the square root of a negative, does anybody remember what we do with that? Like if I were doing the square root of -4? Yeah, we're going to have an imaginary number and we'll talk about that, okay? All right, so we got three more. Tammy, Nathan, and Hope. Tammy, tell us what they did wrong here.
On that one, you can't just count.
Good. Very good. That's exactly right. Okay, what they did there is they canceled terms instead of factors.
So
Tammy looked at the pen, made sure she wasn't putting her finger on the button. That's great.
you can break it into different fractions. So
And that's all you can do. Okay? Oh, I'm sorry. You can, yeah.
and then the a can simplify into 1.
That's the correct way to break it up. There's not another way that you're going to be able to break these up here. Again, you can't cancel factors. You can only cancel terms. Okay. Nathan, next one. What did they do wrong here?
What they did is they took the the problem, and they took away this a and that a, but they didn't take away that a at the same time.
So they kind of tried to cancel the term again, didn't they? Just like the one up above. Okay.
But they didn't cancel all the terms.
Yeah.
So
What's the correct way to do that, do you know?
when it just equal x.
Close. Close. Okay.
No, it'd
So-
be 1.
There we go, 1 plus x. So what we do here is we're going to take the a out. So that's going to be an a, and we're left with a 1 plus x right there. So if we look at that, take an a out of both of those, we're left with a 1 from the first one, we're left with an x from the second one. Now what can we do?
You would take away the a's.
Now you can cancel the a's. The a's cancel to be 1. That's the right way to do that one there. So you'll notice on this one, it's like they tried to cancel the a with the a and just leave the 1 and leave the bx alone. Here it looks like they canceled this a with that a and left that a alone. Both of those are wrong, okay? The other way that we could do this is we could, kind of like Tammy did up here, let's do a over a plus ax over a. You can cancel those to be a 1, and you can cancel those to be an x. That's why the answer that's left is just 1 plus x. Okay? Hope, the last one.
They were dividing it by x, but
Really silly mistake there, right? I mean, not many people would make that mistake. So the correct way to do it, I'm not even sure what they did here. Can anybody see why somebody would make this mistake right here? Maybe cancel those. That's a 1 left on top, and then they forget there's a 2 down in the denominator, or something like that. That would be a really silly mistake, okay? If you checked out the section, there are a couple ways that we can avoid making mistakes like that, okay? It says we can often avoid mistakes by working slowly, okay? Writing neatly, okay? And in an organized fashion. Okay, another thing that can help is saying the steps that you're taking out loud. Okay, if I looked at a problem and I said -2 times 4 is 8, okay, I kind of went through that in my mind and just quickly wrote down that that's positive 8. If I say -2 times positive 4 is 8, okay, maybe a little bell will go off and say, wait a minute, I'm multiplying by a negative by a positive. That should be a negative. Okay? And then always ask yourself, does the answer make sense? Okay? Now, sometimes if you've been making the same mistake for a long time, you'll say, yeah, that makes sense. And then you've got to figure out or be taught why it doesn't make sense. Okay? So I'm going to go through these fairly quickly. These are things that, again, in the long run, you're going to be happy if you've kind of locked these away. Some of these are a little bit obscure as far as how often they're used, but let's just run through these. So occasionally we'll write things in an unusually factored form. Like, there's nothing wrong with this. A lot of times we'll just leave an answer like that. But there are many times where if we pull the fraction out front, it makes it a little bit easier to deal with. Every year in my calculus class, we'll see something that looks like this. Let's see. X over 2, believe it or not. And people struggle with what they need to do with that in a calculus setting. And for some reason, it makes a lot of sense, or it's a lot easier if we write it like this. Okay? 1/2 times x. Isn't x over 2 exactly the same as 1/2 times x? Just like on this one right here, this is 5/8 times x to the 4th. Okay? This in calculus would be a more useful form right here. Okay? We can also do the same thing with this one right here. Don't worry about factoring the numerator. What would be helpful on this one is writing this as -1/6. So I take that fraction part, I pull it out front, and what I'm left with here is just a polynomial. So I've got a fraction, ugly part, but then I've got a fairly nice polynomial to deal with here. Okay? We also sometimes, although there's not a whole lot that can be done with this, I suppose we could factor this. I think that does factor. Okay? We could take out a 1/2. And if I take out a 1/2, here's what I'm left with. I'm left with, oops, let's see. Yeah. So take out a 2, I'm sorry. So what I'd be left with here is, oops, take out a 2. Let's see, divide that by 2, I'm left with -1/2 x. Okay, notice how I wrote the coefficient out front. And if I take out a 2, I'm left with -3/2. Okay? Although this looks much worse than it did before, at least we're starting off with a plain old x squared. Okay? So that's the advantage there. And then we've actually done problems like this. This looks really awful, but we can make it a little bit easier by doing this. We can take out the smallest exponent, the most negative one, if you want to think of it that way, which is going to be this right here. So here's how I'm going to write this. I'm going to write this as x over 2, and then x plus 1 to the -1/2. I'm going to divide out an x plus 1 to the -1/2. And then the next one's going to be x plus 1 to the 1/2 divided by x plus 1 to the -1/2. So what I'm doing here is I'm pulling out an x plus 1 to the -1/2. What's left of this one right here once I do that, once I divide out an x to the -1/2? Just an x over 2, okay? And what's left of this one, or what do I get here when I divide x plus 1 to the 1/2 divided by x plus 1 to the -1/2? I subtract the bottom exponent from the top exponent, so that's going to be plus 1/2. So I get x plus 1 to the first, or just x plus 1. Okay? And if you take a look at that, notice we've got this ugly part right here, but then I've got a really nice polynomial that I can work with here. In fact, I can even add those together and get like terms. These two together make 3/2 x plus 1 would be the other way to write that. Okay? Any questions? We usually don't like working with negative exponents, but we can work with negative exponents. Sometimes that's actually helpful. So I'm going to do two things with this. I'm going to write the coefficient out front of 9/5, and then I'm going to write x to the -3. Again, we don't normally like those, but in some cases it's advantageous. And then on this problem right here, 7 is the coefficient, 2x minus 3 in parentheses, and this is a square root. What exponent would that be? 1/2. And it's in the denominator. What happens if I move it into the numerator? This would be -1/2. Okay? Negative means reciprocal, so I'd have 2x minus 3 to the 1/2 in the denominator. 1/2 power is a square root. So that's sometimes an advantageous way of writing that. Okay, so we've done a lot of rewriting fractions here. This is a really good skill, writing a fraction as a sum. Take a look at this right here. I've got x plus 2x squared plus 1 over radical x. Okay, we're going to take this and we're going to break it up into 3 little problems, which is going to seem like a little bit more work. So this is x over the square root of x. This is 2x squared over the square root of x, and then plus 1 over the square root of x. And then I want to simplify each one of those. So this is x to the first over x to the 1/2. What do I do with the exponents? Subtract the bottom from the top. So this is going to be x to the 1/2. That's the first one. This is 2x to the second over x to the 1/2. Again, subtract the exponents. So this is going to be plus 2x to the, if I do 2 minus 1/2, that's going to be 1 1/2, or we'd write that as 3/2. Okay? And then is there anything to simplify here? I could write it with a negative exponent, so I could do x to the negative 1/2. Okay? That right there would be the answer written with exponents. It would be really tempting to take the x to the 1/2 and the x to the negative 1/2 and put the two of those together and get like a 0 or a 1, but is that right? It's not. Okay, because really this is the square root of x if we wrote it as a radical. Okay, this is plus 2 square root of x cubed, and then 1 over the square root of x if we wrote each one of those as radicals. Okay, and then you might take a look at this right here. That middle term can be written this way. Okay, so that's probably the best way to write it. Okay. This problem right here, now it gets a little bit interesting. So I've got 1 plus x over x squared plus 1. 1 plus x over x squared plus 1. Sometimes all you need to do is break it into a couple different fractions and you'll be able to work with it. So if I write this as that term over the entire denominator plus that term over the entire denominator. Okay, believe it or not, you could do something in calculus with both of these. Whereas if you leave it like this, you can't. A lot of what we do, in fact, we'll learn a technique in a couple of weeks. It's mentioned right here. It's called partial fractions. In fact, let's just write that down right now. Okay. Partial fractions. Has anybody seen partial fraction decomposition? Ben has. Okay. Basically what we're doing is we take a fraction and we break it into its parts. Okay. So this is the fraction to begin with. If you break it into the two fractions that it came from, it would be these two pieces right here. And we'll learn how to do that. That sometimes can be an advantage. Okay? And then on this one right here, this is kind of an interesting technique. What we're going to do is, and mathematicians do this quite often, we're going to add something in and then subtract it off at the same time. So here's what we're going to do. We're going to do 2x minus 2. We'll do plus 2 and then minus 2. And then this is x squared plus 2x plus 1. And then we're going to take this and we're going to break it up into a couple of different pieces. We're going to break it into these two pieces on the top. Okay, so we'll put those two together on the top and then minus that last one over that one. Okay? And again, it doesn't look like it. It looks like we've made this worse, but with that part right there, relatively easy to do some calculus on that. And this one right here, there's one other thing that I can do with this. I could rewrite this as negative 2 over x plus 1 quantity squared. So if I use these two terms instead of this and instead of the original one, I can actually do some calculus work on this. Okay? All right. And then this one's kind of interesting. Here's how we're going to do this one. Okay? Has anybody heard of polynomial division? Learned how to divide polynomials? Raise your hand if you've seen that. A couple of you. Okay? So here's what we're going to do on this one. Instead of adding something in and subtracting it off, we're going to do it like this. I'm going to write x squared minus 1 on the top. Now, is that exactly the same as what was on the top? Yeah, it's just written differently. and then this is x plus 1. Then I'm going to rewrite this as x squared minus 1 over x plus 1 minus 1 over x plus 1. Legal move here, just rewrote the way I wrote the 2. Legal move here, I broke it into those two terms over the denominator, the entire denominator, and then minus that term over the denominator. Okay? And then there's not much that you can do with this right here. Does anybody recognize part of this? What is it, Lynn? It is a difference of squares. So I'm going to write that as x minus 1 and x plus 1 over x plus 1. And minus 1 over x plus 1. And what can I do here? You can cancel those off. So this is x minus 1 minus 1 over x plus 1. Okay? And again, much more useful form as far as calculus goes. Okay? And then the last couple. So an interesting factoring of terms, or factors in terms. So again, along with the idea of adding 2 and then subtracting 2, what if I take this expression right here and I put a 1/2 out front? So I times it by a half and then multiply it by 2 at the same time. Seems really silly because wouldn't the 2's cancel and we get right back where we started? Okay. But again, in calculus, that's a nice form to have right here. Let's take a look at this one right here. If I divided by 12 and at the same time multiplied by 12, there's the 7/12. Okay, there's this right here, and there's the 12x squared. Again, you would never want to do this in a regular old algebra class or a pre-calculus class. Okay, but adding something in and subtracting it off, multiplying by a factor, dividing by that same factor, can be advantageous. And then this one right here may look a little bit familiar to some of you. Here's what we're going to do with this one. Instead of having the 4 on the top, we're going to do x squared over 9/4. Okay? We're going to kind of divide the top and bottom by 4. So this would be minus y squared, and the bottom was a 1. If you divide that by a 4, you're going to have a 1/4 down here, and that equals 1. And the reason this is advantageous is this is a shape called an ellipse, an oval. Okay? Maybe some of you have seen that before. And if we write it in this form, you can tell what the graph looks like. Okay? Kind of a pain in the butt either way. This is another one of those where we add 1 and subtract 1, and then break it up. If I do x plus 1 over x plus 1, I get a 1, and then it would be minus 1 over x plus 1. Okay? Again, doesn't happen very often, but some good skills to have. Certainly nothing that you need to memorize there. Just be aware of those, and if that comes up at some point in the future, sometime in the next couple of years, say, oh yeah, I remember seeing something like that. Okay, that's okay to do. Might be worth kind of reviewing each one of those. They're also in your textbook, and you can take a look at those. So let's say we had a really ugly expression like this and we wanted to simplify it, okay, using some of these techniques that we've talked about. Any ideas here? Is there anything that we could just flat out simplify? Okay, x to the what? Okay, well, let's take a look at just this term right here. Let's just focus on that one. Couldn't I rewrite that as I've got a 2x here, and I've got a negative 3, and I've got an x to the 5th? Could I write that as negative 6x to the 6th? And then this part is x squared plus 1 raised to the negative 4. Okay, could I clean this up at all? Could I make that look a little bit better? We've got a negative. How about we write 5x to the 4th out here, and then x squared plus 1 raised to the negative 3 here. And what about the denominator? X to the 10th. X to the 10th. Now, if I'm going to cancel anything, I want to factor it out. I've got to cancel factors, so I would want to factor the numerator. So if I'm going to factor the numerator, let's take a look here. What can I take out of both terms? Peyton? I can take out an x squared plus 1. What kind of x squared plus 1? Would I take out a -4 of them or -3 of them? Anybody remember? Always, it's the smallest one, okay, the one the furthest to the left side of the number line. So we're going to take out an x to the -4. What else can I take out of the numerator? X to the 4th. Okay, I can take out an x to the 4th. Okay, if I do that, I'm left with a -6. We haven't touched that at all. What happens if I take x to the 6th and divide it by x to the 4th? X to the 2nd. Okay, so this would be x to the 2nd. What happens if I take out all of that x squared plus 1 to the -4? What if I divide out an x squared plus 1 to the -4? That whole thing is gone. So this is all that's left of the first one. Okay? Now, did I touch the -5? Nope. So that's a -5. How many x's did I take out? All 4 of them, so those are gone. Okay, and if I took x squared plus 1 to the -3 and I divided out an x squared plus 1 to the -4, what do I do with these exponents again? Subtract the bottom one from the top. So that's going to be minus a -4. What's a -4? Plus 4. So this is going to be x squared plus 1 raised to the 1st. All over x to the 10th. Okay, now let's see what we can factor, or what we can cancel. I've got 4 x's here and I've got 10 of them down there. Those 4 are going to cancel with 4 of these, so that's going to be to the 6th. I'm going to have an x to the 6th in the denominator. I'm going to have an x squared plus 1 raised to the -4 here. And then can I do anything here to clean this up? Okay. Distribute the 5 through, so that's going to be -5x squared, and that's going to be -5. So I get -11x squared altogether, and then -5, right? I would say that is by far the nastiest answer we've gotten so far. But is it better than the original problem? Look at that original problem there. Okay, looks a little better. Okay. Now there aren't. I didn't assign. I mean, there's not a ton of problems. I mean, most of this was just kind of looking at these and understanding. Okay, here's a common mistake. Don't make that. Or here's maybe a different way you could think of this type of problem that in the long run will be much better once you get to calculus. Okay. Any questions? Okay.